Thanks, Professor Madhukan, for the introduction. Frankly speaking, I am an engineer only, not a mathematician. So I need help from my mathematician friends to, increase the level of research to one step further. So even this is the first time that I am giving a presentation for the people who are all mathematicians, and I think very few will be from engineering background. But so let us, I will try my best to, give you a flavor of machine learning, and I will try my best to link it to somewhat to the, your mathematics part. And we will try to see what can be done and what can be explored for future research. So let me share my screen, and then we will start the lecture for today's. Yeah, so actually, the way I will be progressing for this presentation will be that I will be going with the machine learning introduction, the basics of it, like what machine learning is all about.
Professor Ahlad, is it possible for you to make it full screen presentation?
Yeah, I will do it. I will do it. Just a second. I was just briefing them with the, today's schedule. So I will be presenting you with the fundamentals of the machine learning first, and then at the end of once you are a bit aware of it, then we will start with the installation of Anaconda and all these Python libraries. I will give you the screenshot view of how it is done so that you will get aware of this thing. And in the coming session, which is in the evening, what we will do is we will actually go slightly again into the details of the machine learning by, exploring neural networks. And then I will link that neural network to the differential equations, which will be, done in the evening session so that you will get to know what is the connection between them, how we can explore it further. And at the end, we will have a small exercise which will help you out in gaining more experience in how to do it. So let me share, let me make this screen a little, in a presentation mode. Just a second. Is it okay now?
Yes, it's perfect.
Okay. Okay. So to start with, let me show basically the fundamental question that we have in the area of machine learning. That is, what is basically machine learning? So machine learning algorithms actually it's nothing but it's basically a developing of a mathematical model based on the sample data which you are using as a training data. So for example, on the left side, you have a lot of training data and you want to actually, try to find out or try to uncover the mathematical behavior which is actually underlying this, data corpus. So machine learning algorithms are actually trying to find out, or you can say it tries to uncover the mathematical, framework which is lying behind it, which actually will help you out in generating this data. So that is what is written over here. That is, machine learning algorithms develop a mathematical model based on the sample data, which is known as a training data, in order to make predictions or decisions without being explicitly programmed to do so. So basically, based on the training data, what happens is our machine learning algorithm will try to find out a function which is lying or which is hidden inside this data corpus, and it's very difficult for the human person to actually find out how this data is generated until unless he is a very proficient experienced person in this area. But still, after so much of experience in dealing with some kind from this kind of data, whether it's medical data or image data or satellite data, still people are far behind what machine learning can do, because machine learning can actually uncover the non-linearities or the hidden mystery which is lying behind the data. So this is what actually machine learning is all about. It tries to uncover the hidden function which is lying, and it will generate some function fx which will help you out in doing some predictions or classifications, which we will see in the coming slides. So basically it's showing you a small diagram which says that you have a data corpus which is written in this which is drawn in this cylindrical box. So it has a lot of data, and machine learning is used as a model M. So what it says is the machine learning model actually takes this data and it will generate that function fx which I was telling you in the earlier slide, and based on this basically once you have this function fx, then you can have some external data which is not there in this data, and we call that external data as testing data, and this data we call it as learning data, training data, sorry. So the testing data which is coming from here will not be there in the training data. So once you feed that testing data here, it should give you some inference, like some prediction of some prediction of some value or classification. So we will discuss all this in our coming slides. Do not worry about it. So let me go to the next slide, please. Okay, so before going any further, what I want to raise some curiosity in you by showing you some videos, by showing you the area where machine learning and deep learning has already reached, so that you can have a brief idea that how far we have already gone in this area. But there are some more areas of research which are still required. It's not the end of the story, but this is the state of the art which is currently going on in the area of machine learning, deep learning, and natural language processing. So I will play some brief videos, and please see the areas where it is actually applied and how far we have reached in terms of the technology. So currently here, this video is about the company Amazon, and you can see using the area of machine learning and deep learning how people are actually shopping in the Amazon shop. So basically they are not the billing is all automatically. So let me play this video for you so that you can see whether how it is happening.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go.
So is that video's voice was audible to all of you? Kindly let me know. Was the voice audible? Okay, okay. So this is basically one of the latest shopping centers which are opened in US, and you can see the quality of work which is already these people have achieved in the area of machine learning and deep learning. So let me show you a few more videos to give you more insights. So this is a video of Google Duplex. So it is basically based on natural language processing, which is again the advanced version of machine learning, but it's close to deep learning. So here you will see that how a mobile or automated query is answered. Basically, when you will be asking some questions to the to the chat bots, if you must have seen it on in various hospitals. So you will see the website with having chatbots on the right side. So when you ask some question to it, it will automatically answer your queries. So that is actually one of the examples of using natural language processing in this area. So this Google Duplex is again showing you one of the chatbots which actually use natural language processing. Again, the advanced version of machine learning. So let me show you this video, please.
The progress with our system. As I said earlier, my vision for our system is to help you get things done. It turns out a big part of getting things done is making a phone call. You want to get an oil change schedule, we call a plumber in the middle of the week, or even schedule a haircut appointment. We are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's your first name? Your first name is Lisa? Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
The progress with the assistant.
So you can see now like how they have come up with this Google Duplex, which actually is replacing the person itself, and the person is actually, the machine is actually booking appointment in place of you. So this is one of the very good examples of natural language processing, which is, again, I told you earlier, it's a advanced version of machine learning. So let me show you another one. So this is basically, I think most of you must have seen it on your smart TV. So here you have this Netflix recommendation MITV, or maybe, you know, a patch wall, which you call it in MITV. So here you can see whatever videos or whatever you know, pictures you will see, you will be surprised that similar content or maybe somewhat close content of that will be, you know, shown to you, so that you will be addicted to watch similar content. So for example, if you are watching some action movie like, you know, Stranger Things, then you will be, you know, given suggestions based on that, you know, same action movie. So for example, this Mortal Kombat will start coming up on your, you know, screen. So and then you have this Marvel Studios Loki. So this is basically, all these are the action movies. And you know, once you have watched it, or once you have watched a single movie, then automatically Netflix or maybe, you know, Amazon, any other streaming, you know, media, it will try to give you similar content based on that. So this is basically one of the famous problems in the area of machine learning, which is basically Netflix recommendation. So it tries to give you recommendation on your base, on your interest. So once you select anything, so it's actually tracking your interest. So the computer, the machines which are there around you, even the mobile phones, they are all tracking your activities, and based on your interest, they are showing you the advertisements by the companies which are actually, you know, trying to sell their products. So this is one of the latest examples which you are actually normally using every day, and I don't know whether you know it, but this is one of the good examples of machine learning. So the strategy which actually Netflix, basically adopts is that it will actually monitor your interaction with their service. And the other members which are actually having this similar taste and preferences will also be monitored, and they will give you information based on these titles, such as, you know, the categories, the actors, the release year. So they will actually try to cluster you as well as the other members who are actually watching this similar, you know, similar type of movies. So this is basically the clustering they are actually forming, and in that cluster they will put people with similar taste. So all this clustering and all this, you know, forming of a small cluster of similar people will be done through machine learning and deep learning. And Actually, also along with this type of things which they are, noticing about you, they will also notice that how much time you are in particular day you are watching Netflix, and on which devices you are watching Netflix, and how long you are watching Netflix. So this is also they are recording. So all these informations which are, I am listing out here, they are called as features for machine learning. So we will see now in a few minutes that what features are, but please remember that these are the practical features which actually they keep in mind while making some decisions about your interest. So we will see what these features are in detail in our coming slides. So again, a very beautiful example of deep learning and machine learning, which is self-driving cars. So let me show you a small video for that also.
Driving requires a lot from us. All just to get around. We can do better. What if the world's most experienced driver was at your fingertips? A fully self-driving car, ready to take you where you need to go. A ride designed for you, giving you more time for the things that matter most. What if getting there felt like being there? This is where we're going. Introducing the self-driving service, Waymo One.
So you can see now how people have achieved the state-of-the-art self-driving cars where there are no drivers, and the car is driving itself based on the training that they have received. Like these cars are they were trained for driving long hours. So this is actually one of the recent examples of the state-of-the-art work which people have done in this area, and this is self-driving cars. So another area where machine learning is applied is in farms. So let us see a small video for this. So you can see now how machine learning is applied in the area of farming, where these robots are taking place of farmers, and they are more efficient compared to doing this type of jobs where you have to do some production work, and they will also do not they will be these robots will be working 24 hours. So there is no there is no time duration also, and they can actually increase the production of the crop multiple times compared to the humans. So you can see now the area where machine learning is used in farms. So the next question that I will ask you is that, are there any failure stories because I have just shown you all these success stories. So let us see whether there are some failure stories also to machine learning and deep learning or not, because we are always listening good about machine learning and deep learning. So we want to see the negative aspects of that machine learning and deep learning also. So let us see whether, we have some failure stories or not. So I will show you some very critical failure stories which are actually harmful for us. So let me show you that. So this is basically, a accident which happened due to the self-driving car. So you can see it's showing you the incident where, a person was, sleeping during that time, and the self-driving car was not able to judge some parameters like whether that has to accelerate or deaccelerate. So I'm not showing this video, but actually you can get the idea that self-driving cars are not as perfect as we are thinking right now. So it's very difficult situation that we should not rely completely on the technology. Somewhere or the other, human intervention is also required. So this is actually, a video of a clipping from a news channel where the self-driving car got bumped into a highway. So this is actually not advisable when you are completely depending upon the technology.
Deadly crack.
The second one is again one of the very, problematic situations where person is actually impersonating another person using his own voice. So let me show this video without, going further in details of it. By seeing the video, you will understand how it is happening.
It got me thinking about my full-time employees and their ability to survive on $8 an hour in New York City. And foremost in all of our minds has been the loss.
So you can see that the Barack Obama who is speaking, this footage is actually faked. Somebody else is speaking in place of his voice, and he is mimicking his face. So you can see how this is again a very problematic situation.
The grief felt by the people of Orlando. Most of us don't get our health care through the marketplace. We get it through our job or through Medicare or Medicare. And what you should know is that thanks to the Affordable Care Act, your coverage is better today than it was before. Women can get free checkups, and you can't get charged more just for being a woman. To give his employees hope together to pass a bill that would boost America's very, very hard times.
And progress, at least within the small confines of the legal community. I think it's really important.
Here we go. President Barack Obama.
So you can see how this person is actually speaking, and whatever he is speaking will be impersonated on this person. So you can see how this lip movements of this person will get onto this.
When you're giving a speech, make sure you use a lot of pauses.
America's businesses have created 14.5 million new jobs over 75 straight months.
We're developing technology. Every technology can.
So you can see now like how a person can, post his views on somebody else. So it's very difficult to even recognize whether the President Obama actually told these statements or somebody else has forced his views onto, his, speech. So that is again one of the, major hurdles that we are facing in the area of machine learning and deep learning, because these projects are, so much advanced that it's very difficult to actually detect the real person behind it, whether the video is fake or not.
It got me thinking about.
Then there is a recent issue which happened in Google. So I will show you. It's a bit funny video, but maybe I hope you will be understanding the story behind it. So it's a search result bias. So basically when you are searching something, and if you are discussing a specific keyword for a specific person, then it creates a bias, and Google will not understand, Google search will not understand whether that word is actually for that person or not. So it's very difficult to, address this situation. And you can see how because of this, Google was given a summon from the court, and the person, this Sundar Pichai had to answer why this particular thing is happening in US. So I will show you this video here, and you can yourself understand how difficult it is and how, problematic it is for some person with whom this is happening. So let me show you this video.
Manipulation of search results. I think it's important to talk about how search works. Right now, if you Google the word idiot under images, a picture of Donald Trump comes up. I just did that. How would that happen? How does search work so that that would occur?
We provide search today for any time you type in a keyword. We, as Google, we've gone out and crawled and stored copies of billions of web pages in our index. And we take the keyword and match it against web pages and rank them based on over 200 signals. Things like relevance, freshness, popularity, how other people are using it. And based on that, at any given time, we try to rank and find the best results for that query. And then we evaluate them with external raters to make sure that, and they evaluate it to objective guidelines. And that's how we make sure the process is working.
So it's not some little man sitting behind the curtain figuring out what we're going to show the user. It's basically a compilation of what users are generating and trying to sort through that information.
Last year, we served over 3 trillion.
So you can see now like how this particular keyword idiot is related to Donald Trump, because so many people have, tried to, use that word on web pages. And what machine has done is it has assumed that this particular person is related to this keyword. So it's again one of the, unfortunate situations where machine learning and deep learning is trying to not recognize whether this keyword is actually related to some person, or is it like, people are using it for their own, convenience. So this is basically again one of the drawbacks for the machine learning and deep learning. So let me have a quick check. Am I audible to all of you, please? Can anyone just give a quick feedback?
Yes, sir. Yeah.
Okay, fine. So this is again was showing you this thing, and let me go further.
Manipulation of.
Okay, so now all this I think must have given you some curiosity of learning the area of machine learning and deep learning. So let's go into the details of the ML, and I will give you brief overview of it so that you can go at your own pace in understanding this particular area if you are interested. And the only prerequisites to understand this area of machine learning is linear algebra, probability statistics, and optimization, which I know that you people are already aware of. So there is no one stopping you to enter in this area. So my job is to just give you a brief introduction to this course, and you are good to go after that. So let me go further. This is just showing a brief. I was giving some slides to some other students which were from undergrad students. So this I just kept there for their understanding. But somewhat I was trying to say that where the linear algebra is actually used in the area of machine learning. So here actually we use one-dimensional, two-dimensional matrices as well as tensors also in the area of machine learning. So it is showing you that. And again, actually the linear algebra is applied in various areas of ML, such as data representation, processing, machine learning, deep learning, NLP. So there is nowhere you will escape from this linear algebra. So it's a basic, backbone to understand the area of machine learning. And again, what are the basic use? So this is basically showing you a brief introduction of how linear algebra is actually what kind of things like matrices, vectors, vector norms, matrix vector rules, matrix calculus, where they are actually used in the area of machine learning. So this was the thing for just for the introduction. So now we enter into the basic idea, like what typically a machine learning intelligence pipeline is. So this is actually one of the important pipelines which remains constant throughout in all the areas where you will go, like whether you go for machine learning, whether you go for deep learning, whether you go for natural language processing, whether you go for reinforcement learning, this particular pipeline will remain constant throughout. So my take on this particular slide is to make you understand all these steps one by one, so that you can understand what's going on and you can go further and understand various algorithms which are present. So every algorithm will be actually using all these basically 5 steps. So the first step, which is actually numbered 0, is called as the defining of the task. So whether you are doing a cats versus dog classification, which is currently I am doing here, but depending upon your area, whether you are doing some mathematical area or maybe some other problem statement, the important thing is to define the task first. And once you have that task in your mind, then the second thing is to collect the data related to it. So data collection is also one of the important, steps in the area of machine intelligence. And in the data, we actually try to divide the data into two parts. One is called as the training data, another one is called as the testing data. So we will discuss this in the coming slides. And once we have this data, the third important aspect that you have, which is very important, is to design features. Please recall the Netflix recommendation slide, which I was telling you. In that, I have shown you some 5 or 6 points which Netflix is trying to, take from your side. Like, you don't know whether you are giving that features to them or not, but automatically Netflix is actually learning that from you. So it's basically the features which are important. And then once you have these features, then you go for training the model. And once you have this model done, then you go for the testing of the model, whether that model is actually working as per your expectations or not. So these are the 5 different steps. So let us go to each of these individual steps and see what these steps are, so that you will understand what machine intelligence is. So the first step is data collection. So in particularly in this slide, we are trying to show you, like, the problem statement is to distinguish between cats and dogs. So what we want from our machine learning is that machine learning should give us the answer that if I give the machine learning image, then the machine learning should tell that whether it's a cat image or a dog image. So in order to make it understand whether it's a cat image or a dog image, what we have to do is, first of all, we have to collect the data related to cats and dogs, so that they can be so that the machine can understand first. So this is basically the idea of data collection, where we will collect all the cat images and all the dog images, and we will keep them in a training data set. Okay, the second task is basically to define the features. So basically what happens is, I just want to give you a brief idea of how this idea of features came to in mind for these, for the engineering people. So what happened was, like, they went to a biomedical doctor and they wanted to understand that what person sees or what goes in his mind when the person sees the images. So when the engineers actually contacted the medical doctors, and after a several survey and research, what they have found is that in our brain there are some points where actually the images are not perceived as images, but they are perceived as these images which are on the right side. And you can see in this particular image, most of the content is in this direction. So you can see the direction of the arrow which I am moving. So most of the content is on like this, in a diagonal phase. And in this, most of the content is in this, in this shape. So you can see you are having only edges in the images. So this edges concept is coming from image processing. I do not know whether you have gone through that area or not, but if I want to explain you in very simple language, it is basically images are there, but you have boundaries of that images. So in this particular image, you can see the edges are in this direction. So what happens is, our actually brain is not processing the complete image, but it is processing the edges of these image, and then it is all combined together to give you a feeling that you are watching an image. So basically from this from this discussion with the medical doctors, the researchers have found out that the important thing is we have to learn these features which is given over here. So that's why the term features started out in the area of machine learning, because they wanted to understand that how brain is working. So they want to mimic the same thing on computer. So that's why these feature stories started to play. So that's why the importance of features is coming, because based on these features only a person is actually distinguishing the photos. Okay, so in our cats versus dog classification, as I told you, the features are important. So if I want to separate the cats from dogs, so what I do in this particular case is I will take nose size as well as ear shape as features. So now you can see that you will all agree that most of the dogs will have the big nose and they will have very small nose. No, sorry, they will not have very small nose, but they will always have, mostly most of them will have big nose. So this is actually one of the features which will help to separate dogs from cats, because cats mostly have a small nose. And in order to, and there are some situations where, nose size of a dog can also be small. So what will happen in that case, this particular picture of this particular dog may be this side because of the nose size. So in order to have further separation between the two classes of cats and dogs, we include one more feature, which is ear shape. So you will all agree that, most of the cats will have pointy ears and most of the dogs will have round ears. So if you add this feature, which is ear shape, it will actually help you in separating these two classes again more further apart. Otherwise, if you have only nose size, then this particular dog will create a problem because its nose is also small. So it is lying in the between, it is lying in between. But now as you added one feature more, then the separation between the two classes is increased. So this will help you out in separating the two classes. So the important thing is, if you add further features, it will further, make the distance between this class and this class, it will further move them apart. So the more features you try to bring into the problem, the more better it becomes. But there is a limit to that also. You cannot increase the features arbitrarily, but there is a limit which I will not discuss here, but you understand what I am trying to say in terms of the feature designing. So now this particular step is over. Now the third step is to train the models. So let us see what that means. To training the model means to actually separate the two classes. So let me share this screen first. So here, if you see that here we have these two classes, one is the cat, another one is dog. So if I want to separate the two classes, what I will do is, if I can draw a line like this, if you are able to see this black line, so if I can draw a line like this, then you can easily separate the two classes because you have drawn a line on this picture. So what machine learning tries to do is, it tries to draw this line, which it draws automatically rather than a person drawing it. So this is the important part which machine learning is playing a role in. So let us see how this line is actually formed. So this line is actually formed using this model. So model actually using this flow chart, actually this line is formed, which I was just showing you. So what happens is, you have some data. As I told you, in cats and dogs, you will have some training data here. So what you will do is, you will feed this training data into this model. This model I will explain you in the coming slides, but right now you can assume that this is a model which will try to distinguish between the two dogs and cats and dog images. So this model requires input data. So input data is going into this model. What will happen in the initial phases? This model will make errors because it is started to learning the cats and dogs. So obviously, even if a person is learning something new, it will try to make errors in that. For example, if a growing child, if you show him some pictures of apple and orange, you will see that person will, the child will actually make some mistakes in the initial days. So similar thing will happen with models. If you try to show this model cats and dog images, it will make some prediction error. And this error, what we do is, if it is making that error, what we do is, we take this error and we take the actual output of that image, which is, this is a dog or a cat. We already know that. So that output, which is an actual output, and the predicted output, which is here, we calculate the difference between the two. And when you calculate the difference between the predicted output and the target output, that we call as a loss function. So please note that this loss function is very important, and we will discuss this in differential equations also once we discuss that in our next session. So please note that this idea should be clear in you, that what is actually the loss function. Loss function is nothing but it's a target output minus the predicted output. So once you have this loss function, you feed it into the optimization strategies, various optimization strategies. And what they do is, once you feed it into the optimization strategies, optimization will make this model learn much better now. So optimization will actually help this model to learn, and model will become smarter and smarter and smarter with this optimization method which you use and which requires loss function as the input. So this is the pipeline, and it will continue to move in this way as you feed in more data. So if you keep on feeding data, you will make your model learn more and more and more. So this is basically the training of the model which happens in the area of machine learning, and it remains constant throughout, irrespective of the algorithms that you will use in ML or the algorithms that you use in DL or your algorithms you use in natural language processing. So this always remains there. Okay, this slide I have already shown you. So this is training the model. Now the last step is to test the model. So once you have trained the model, let us test it also, which is again very important step. But the main thing that you have to keep in mind is, while testing the model, the images that you select should not be from the training model. So all these images which you had taken earlier, if you see the images which you have taken here, which are training images, you have to make sure that these training images were used for learning the model. But when testing the model, you cannot use these same images. You have to use different images of cats and dogs, because we do not want our model to learn from the already learned images. We want them to learn from the different images which are not there in the training images. So this is important. So our machine learning model should predict that this is a cat image and this is a dog image. So the important thing is, in testing the model, what we are doing, we are actually putting all these images which are into testing, and you can see our model is correctly predicting whether you have a cat image on this side and dog images on this side. But note, there is one image which is this image. This is actually, our model is making mistakes. So you can see this particular image is of dog image, but it is kept in the class of cat images. So it has, the mistake is created over here. And the reason for that is because, this dog is having pointy ears. So even keeping this dog is having pointy ears, as well as the nose is also small. That's why, these two features were not able to separate this dog, and that's why this error is created. And you can see now, our model is also creating errors. So this shows that even when you train the machine learning model, it will not be perfect. It will make some errors, and that errors is also called as training errors and testing errors. So in this particular case, it is called as testing error, because during the testing, it is creating error. In the training also, it will create errors. That is also called as training errors. So this has to keep in mind in order to make this further robust. You can add one more feature also, which you can say eye color. So if you take eye color as brown and green, then most of the colors of the eyes of the cats are green. So but some of them do have brown, but you can take that also as one of the features, and then you can separate this dog also. So here you can see, even with these two features are not enough to separate this particular image, which is of dog image. So there are two types of problems in the area of machine learning. One is regression. So in this particular case, what we have is, we have this data set, as you can see over here. So what we do is, we try to fit a line in between it so that it can actually, reduce the error between the various data points. And the line which actually creates a minimum error among these data points is actually the best fit that you can have. So basically, regression, which is, again, you must be knowing it, but it's again a fancy term. Machine learning is attached to it. So basically, what it is trying to do is, it is trying to fit a linear fit onto the set of data points. And the idea is to, if you are using a new revenue, if you want to understand the revenue of a company which is not already there here. So these data points are training data points, and this data point is a testing data point. So if you want to actually if you want to know the share price of this new company, then what you can do is, you can actually go onto this line which is already fitted using machine learning model to get to the estimated share price, like what price this particular company will be quoting or what is the revenue of that. So basically the idea is to actually learn this straight line using the machine learning models. So this is actually the idea of regression. Again, this slide is coming back because it's a main workforce for the machine learning algorithms. So in the regression setting, what we normally do is we take the loss function as mean squared error loss. So we try to subtract the actual output from the predicted output, and we do a loss function on it, and that loss function we are taking as mean squared error. And what we do is we feed this loss into the optimization method, which actually in this particular case I am using stochastic gradient descent. But if you go for some other methods, then there are a lot of other methods which are gradient descent, Adam optimizer. So there are tons of optimization methods which maybe you have studied in your courses also. That optimization methods can be incorporated here to do some kind of better research. So optimization methods will try to actually tune these models. So right now in this particular model, which I was telling you, it's a straight line. So what we are doing right now is, in the earlier case, I just wrote model, but now it's a line which is given by y is equal to kx plus n, where k is the slope and n is the intercept of the line. And what this gradient descent will do is it will try to update the values of k and it will try to update the values of n to come up with the new model. And why only k and n? Because if you vary the k and n, it will vary the slope as well as the intercept of the line, and x is the data point. So by varying the slope and the intercept of the data line, a new model can be formulated, and we want to select that model which actually reduces the loss function towards the zero. So that is why this pipeline is actually continuously moving with different target inputs. So this is actually the regression flow chart. So you can see here now a visual representation which is implemented in MATLAB, and you can see how this particular blue line is progressively going towards the best fit. It started with a flat line, and then it gradually fitted into this data points, and you can see how the epochs means how many iterations you are running on this particular data set. So with the initial epochs to 10,000 epochs, it is giving you a best fit line, and that can be measured using this training error, which is going flat to 0.1, and it started out with some value of 0.38 or something. And you can see here how it is done in a more animation type of thing. The important part is, as I was telling you, related to optimization. So what happens is the loss function which we were discussing earlier, this loss function actually is a convex loss function which we have in the case of mean square error. So what we are trying to do is we are actually trying to come up from this point which we have initially started off with. So if you have this point, at this point corresponds to some intercept as well as slope for a particular cost function, because cost function is actually a a function of slope as well as the intercept. So once you are at this point, means you are actually at a very different position in the cost function, and you can see you are making lot of error here because it's not a best fit line. So you are actually currently at this at this point. So now using the optimization strategy, you will be going closer and closer towards the 0th point, or you can say the minima point. So this is the minimum point where you will be going down, and you can see in the convex functions you have always a global minima. So you will actually use the optimization strategy like gradient descent, and that gradient descent will actually try to move this point towards the to the global minima. And you can see once you hit this global minima, you can actually get the a line which is having a mean square error at the minimum value. So this is the best fit line corresponding to this point. So it is showing you a contour plot of the cost function and how the point is actually moving from the maximum to a minimum point using the gradient descent or stochastic gradient descent optimization schemes. Any questions till now? If anyone has any question, you can please ask me. Okay. So another important picture that I'm trying to show over here is that you must have seen in your digital cameras that when you will be clicking using the Nikon or maybe Canon digital camera, you will be, if you see this LCD screen at the back, you will see the faces of the person. Along with that, you will have boxes forming around their faces. So you might be wondering that how come these boxes are coming across these faces, like, on top of these faces. And even in the earlier cameras, we used to have smile shutter. So whenever a person is smiling, what will happen is your shutter will be, the shutter will go up and, it will click the photo. So basically, this particular feature, which is coming through smile shutter or the face recognition feature, again is the one of the advanced concepts of machine learning and deep learning. So let me tell you in which category it lies. So it basically lies in the category of classification. Earlier, I was discussing regression. Now I am discussing classification. So this particular practical example which I had shown you is basically the idea of classification. So here what we are trying to do is we are actually trying to take sample of faces and non-faces images. So here, if you take sample of these face images, what we do is we actually represent them as a point in the multi-dimensional feature space. So if the feature space is same as the dimension of the image, then this particular face, which is a 28 cross in 28, will be actually a point in a 784 dimension feature space. So all these faces will be represented as a point, and all the non-faces images will be represented as a red points. So our target in our classification strategy will be to again come up with this line which is showing over here to separate the faces from non-faces. So this type of category where the algorithms have to decide whether a particular image is having a face or not a face, it's again a classification problem, and it is similar to the problem which we were discussing in case of cats versus dog. Same thing. So you can see here how all these red points are actually the non-faces, all the blue points are the face images, and all these images which we have gathered are called as training images. And once we have these training images, we can actually use our training strategy which we were discussing last time to separate the two classes using this particular boundary. So it separates the two classes. And now when you put a test point here, which is a face point, so this is not there in this particular sample. So these are all training sample. This is the testing sample, and this sample is not there in either of these two. So once you have this sample here, so what will happen now? It will actually, our algorithm should tell it that whether it belongs to this class or this class. So this prediction is correct, that our algorithm has predicted it correctly, that it's a blue point and it belongs to a face image rather than the non-face image. So it's a classification problem which we have discussed here. Again, same flowchart for the classification also. And the important thing is whether you do anything in a machine learning, whichever algorithm you use, whether you go to deep learning or NLP, this particular flowchart will always be there. But the only difference will be some things will be placed here, some different things will be here, some different things will be here. But as a whole, the problem statement will remain like this only. So here, the only difference that you will find out is that you have a sigmoid function operated on this. I don't want to go into the details of this particular function because otherwise it will again, I have to discuss more about it then. But you can Google yourself that what this sigmoid is and how it is operated on this particular model, so that the same model which we were using earlier as a linear regression model is now working as a classification model. So using this particular function, we actually model the same linear model which we were discussing last time as a classification model. And here you can see the animation where the epochs are continuously increasing, and you can see the decision boundary is getting closer and closer to the separating of the two data points. So you can see now as the epoch is continuously going at 3400, the decision boundary has been found and it has separated the data points to its maximum ability. Still, I think some errors were made. You can see here this particular data point was an error, but apart from that, majority of the data points were actually separated by using this line, which is gradually optimizing towards the optimal value. So this is actually showing you how classification is done using machine learning algorithms. Okay, the same logic applies for the classification also, but the cost function will be different. I do not want to go into the details of the cost function. It is called as a binary cross entropy cost function. In the case of linear regression, it is called as minimum mean square error, simple y minus x whole square. But in this particular case, our cost function is completely different. I do not want to go into the details of it because that is not part of this particular series. So, but the important key takeaway point is that the particular cost function which we have taken, which is a binary cross entropy cost function, is also convex. It's not non-convex. So again, we will hit to the global minima and we will be able to find out the good example. So here, if you see, the point is not at the global minima. That's why your curve is actually, making mistakes here, because all these red points were actually non-face images and they are actually lying in the boundary or in the area of face images. So this is not the optimal point where you are starting. But once you go to the global minima, you will get the best line out, which can separate the faces from non-face images. Okay, so now I will leave this slide. After this, we will move to the installation of Python and all that. But I will leave this thing to you, that most of the things that we were discussing till now are all linear cases where you are fitting the linear line. So basically, there are some situations where you have to fit the non-linear line also. So here, instead of using the models with y is equal to mx plus c, you have to come up with non-linear polynomial orders of the model, which can actually fit the data points on the which can actually fit the data points. So for example, in this particular thing, if you observe the data point, you will see that there is a parabolic relation type of thing. So what you will do is you will use a model which is y is equal to alpha x square. So depending upon the type of data, whether it is, and for example here also, if you see the data is moving or positively in a linear fashion, in the other figure data is decreasing in the linear fashion. So depending upon visualizing the data, you will be forming the model. Like you will say, okay, if the data is going up, let us take a positive slope straight line. If a data is going down, let us take a negative slope data line. Or if the data is actually, having some non-linearity, so let us take a polynomial order data, and then we will fit the parameters of that polynomial order. But the important thing is, in the machine learning models, we are calling them as fixed models because we are actually using the handcrafted features. If you recall, regarding the case of cats and dogs, we were actually handcrafting the features ourselves. We were saying, okay, let us take cat ears as pointy or round, or nose as short and big. So all these features were handcrafted. You were crafting the features yourself, but you were not, depending upon the problem, it is handcrafting features. So that is again one of the drawbacks of all the machine learning algorithms which we have till now. But in order to, and similarly, same thing goes with the classification model also. So here you can see, this is not linear, this is non-linear here. So here you can see, if the classes are, like this, you can separate it through straight line. But if the classes are like this, like, so then you have to, create a non-linear boundary like this, or for this particular case also. So depending upon the type of data, you have to actually fit the line linearly or non-linearly. So the major drawback of these models is that you have to come up with the features yourself, and you are by visualizing by inspecting the data set, you will try to do feature engineering yourself, and it is not automatic. So this is the drawback of most of the ML models which we have. So the only way out, is to enter into the area of deep learning, and which starts from neural networks. So neural networks are the networks which actually try to avoid this drawback, and we will see this particular idea of neural network in the coming sessions in the evening. So I will stop my machine learning discussion here. In case if you have any questions, please let me know. Any questions from the audience?
Hello, sir.
Yes, please.
Good morning, sir. So my
Good morning.
question is, what is the upcoming research area, if we can see, in delay differential equation regarding machine learning?
In case of partial differential equations, you are asking?
So delay differential equation.
Can you please speak again? I was not able to understand. Which differential equations?
Delay.
See, my area is not into the area of differential equations too much. So we actually use most of my area is into area of deep learning, machine learning in terms of images. So I do not work in the area too much into differential equations. So, but the important thing is that most of the differential equations, this work has just recently started from 2019. So the things are slowly pacing up, but it will gain momentum, and I think you have to look into these areas in more detail. Okay, I cannot tell the state of the art work going on in the differential equations. Yeah.
Okay, sir. Thank you, sir.
Yeah. Any questions other than that? Okay, so let me share another slide where I will be trying to show you like how to do this installation. Are you able to see the screen?
Yes, yes.
Okay, okay. So basically in Python, so basically what we want to do is like, in the coming lectures, we will be doing some programming on Python also. So basically why actually we require Python, because we have a lot of other programming languages as well. Like MATLAB is there, right? So, and C++ is also there. So basically these are the subtle points which are actually separating Python from others. So it's basically a complete programming language, and it's simple to learn and easy to read and write. So compared to other languages also, it's very easy to write some of the for loops and classes here in Python. So it is again one of the main USPs of Python. And the important and the most important thing is that you can start right away once you install that Python. It's very easy, so it doesn't require too much of expertise to know it before. And it also has excellent libraries which actually simplify your programs. So that is again one of the important USPs of Python. That is, in whatever area you want to work for, the Python will actually have all the libraries available, and it's all state of the art libraries. You can call them and you can use them as per your convenience. So that is again one of the main USPs of using Python. And then it can be used for all the fields of engineering. So that is again another key point. So basically there are multiple ways of working with Python. So I will tell you different ways of working with Python. So the very first thing that you require to do is to basically go and install Python by its initial official website, which is given using this link, and you can choose your version. The basically what I do is actually I use the version 3.6.3. This is very stable version, but people do use some other advanced versions right now. So, but sometimes what happens is some of the softwares actually, they are actually used for this particular version only. So that's why, sometimes incompatibility happens. So it is important to understand that, 3.6 is the very stable version. So we have to actually, use only this particular version. Maybe you can try others also, but it can create some compatibility or incompatibility issues. So the second point is that once your download is complete, you can actually use this exe, flash, which is coming over here, and you can use it to install the Python. So this is the second step for doing it. And then this is actually showing you the progress, like, once you hit that button, you will actually see a setup progress going on like this. So this is over here. And then once it finishes off, you can see the screen saying setup is successful, and you can close the screen. So once it is done, what will happen is it will actually install the Python at a very core level. So that will actually work when you use the DOS screen of your Windows mobile. So you open that terminal window of your basically Windows system, and you can use Python over there, and it's very very simple and basic, and it's not requiring any other interface to do. So it's a very rough way of doing Python. So I would not suggest you to go in using this step, but anyhow you have to actually install these steps, but do not open the terminal window in the Windows, but instead of using terminal windows, you can go for some other editors which are available. On that editors you can actually run Python. So the first editor which actually most of the people use offline. So this particular software is called as PyCharm. So this is actually an offline editor which is available on your desktop itself. So you can actually use this PyCharm and you can run your Python on this particular editor. So let me show you how it is done. So in the first step, what you do is you go to this PyCharm website using this particular thing. You can search it on Google also. This particular website will take you to the PyCharm website, and then you can click on to the community version. You do not click the professional version because it's not it's for paid purpose. So, but this particular community version is an open source. You can download from here. It is available for all the three versions, like all the three operating systems. Depending upon your choice, you can take which one you want, but community version you have to take. And once the download is complete, you actually you will see this window once you hit the exe file. So once you will get this message, you click next over here, and once you click the next button, then you can actually click again next. No need to do anything here in this particular thing. And then you can, depending upon your system, you can take either 32 or 64, but nowadays most of the systems are 64-bit. So you can take this particular tick this and you can go for next. And then what you go is then you install the particular software and you wait for the installation to finish. So once the installation is finished, what will happen is you can actually run your PyCharm Community Edition, which is again a standalone software where you can write your Python programming codes. In the first step where I installed Python, that is actually required, but the important thing is you need a software to write programming language on. That one was quite raw. You have to open the terminal and there you do the Python thing, and actually it's not that. I will not suggest you to do it over here. There you can go for this particular software and install it on your system, and you can you are good to go. So basically this type of window will open and you can create a new project using this PyCharm, and you are good to go. Some subtle points that I wanted to discuss here is, once you create a new project, after that it will ask you some things. So basically it will ask you where the location, where you want to store the particular file. But the important point is this base interpreter. So this base interpreter will only come when you have installed the Python in the first step, which I have told you. So it will give you the location automatically, but if it doesn't give you, then you have to browse to the point where python.exe file is available. So that is actually required. Without this base interpreter, your Python scripts will not be executed. So once this is done, then what will happen is you can create a new project using clicking this file and new, and from there you can actually go to this Python file, and with this opening of the Python file, let us say hello world program, in the Python file, you can actually write your Python commands here in this hello world.py. Py is the extension that is required for the Python files to operate on. And once you have this, you can hit the run button to execute the program. So this is again just showing you the way how Python is actually run on PyCharm. Again, another important software which I would suggest you to use is ANACONDA. So this is again you will find something similar to PyCharm, but the only difference is that ANACONDA is web based as compared to PyCharm, which is standalone on your system. So ANACONDA actually operates on cloud. So what you do is you actually go to this particular website ANACONDA, and there you can actually install the 3.6 or 2.7 version depending upon your choice. But I would suggest go for 3.6. You download this particular software. So once you download, you will get an executable file which you process. You have to just click the buttons, and once you are done, then what you do is you actually click on these particular portions like add this to my environmental variables and this registration, and then once you install, what will happen is all this is showing you the installation screens only. You have to skip this particular step because there is no point in installing the Visual Studio Code because this is not required for this particular software. So avoid using it because it is a very heavy intensive software which can slow your system. So you can skip this. And once you have this installation done, what will happen is you will receive this particular interface. In this interface, there are multiple options available. So here I would suggest you to go for this Jupyter Notebook. This Jupyter Notebook, once you launch it, it will open into web browser. And on that web browser, you can type whatever commands you want to do for Python programming. You can, some of the important point is like, once you install Anaconda, it doesn't require you to install Python first, which I was discussing in the first slide. So that installation is not required because Anaconda already comes with pre-installed Python files. So I would highly recommend you to use Anaconda rather than PyCharm, because PyCharm actually you have to manually install some of the libraries, which makes things cumbersome. Whereas Anaconda already installs some of the libraries automatically by itself, and it will reduce your pain a bit, because you do not want to unnecessary install some of the things which you do not require. But actually PyCharm already do not have any installation libraries it's installed for itself. You have to do it. So this is basically the Jupyter Notebook, where you can launch this particular notebook and you can write your programs here. I would also suggest you can use Spider also. And the reason why I'm saying Spider, because it looks similar to MATLAB, because you people must have used MATLAB for your computing resources. So this Spider is actually very close to the way MATLAB looks. So that's why maybe you can use either this or this. This is my personal suggestion. Maybe you can try something else also, but these are the points that are required for doing the installation of the Python and Anaconda. So from my side, I'm done. In case if anyone has any questions, please ask me. Otherwise, we can close the session. Any questions from the students?
Yes, participants. Okay, I think it was a very motivational and introductory session to mathematicians, that what are the prerequisites for the machine learning, and yeah, Murli, you can.
Good morning, sir.
Yeah.
Yes.
Sir, right. So how to our initiation for Python, very simple installation. At the same time, you have given Anaconda is the best one, right, sir?
Yes, Anaconda. I would suggest you use Anaconda, and another one is Google Colab. So if you are doing very heavy intensive simulations which require a lot of data, then you can go for Google Colab. Actually, Google Colabs give you a GPU, free GPU for for a while, so you can make use of that also. Both of them are good.
Sir, sir, if I want to do line by line compilation, is it possible in Anaconda?
Which one you are saying?
If I want to do, I have a sequence of instructions like a program. So if I want to do line by line compilation.
Yes, it can be done. So we will show you in the next session when we will be simulating a simple differential equation using neural network. Our student will show you, and then he will show you line by line. So then you will understand more about it. We will go into Anaconda and see over there.
Okay, right. Okay. Sir. Thank you, sir.
Okay.
Thank you.
I have to add here one thing, Professor Madhukant, as you were discussing with her, actually I was not able to listen and I was not able to get the term which she was telling, but as you suggested some of the techniques that are required for PDEs to solve it through the famous ones like discretization and all that. But the important thing is I will show one example which actually is a generalized differential equation which can actually solve this PDE. So for your case also it can be solved, but you have to see yourself how to actually formulate the problem in case of machine learning. We will give you one example how to do it for us for a differential equation, that is a diffusion differential equation. Once that is done, then you can yourself take as a motivation and implement that particular delay line which you were telling. And the important thing is every differential equation can be done, but you have to see how to actually formulate the loss function, which I will discuss in the next session. So we'll wait for that. Yeah.
Okay, thank you, sir. Thank you, sir.
One more student is there, Jibitesh Datta.
Yeah, Jibitesh Datta, you have raised your hand. Please ask your question.
Thank you, Professor Ahlad, for your wonderful talk. I got a lot of
Thanks.
motivation. Now, I am working in theoretical physics. I'm using some core mathematics, and I see a lot of machine learning techniques are being used.
Yes.
What is your take on what is the role of mathematicians in this? Because I have seen that most of the things they use some particular model. A particular model, my friends and all, they are using some equation. Apart from then, so what will be the role of mathematician for some definite contribution?
See, right now I can explain a bit of it because right now I'm associated with one of my colleagues here in DA-IICT, and he's also working on theoretical physics. Like for example, we are dealing with plasma. So right now the important thing is as far as the mathematicians and the physicians are concerned, what is most important is to actually come up with the mathematical model which they are actually sorting out with. Like for example, for the plasma physics, like one of my colleagues here in DICT, he has come up with some differential equations related to the behavior of the plasma. And what we are currently doing is to speed that up, the speeding up of that execution, which is done through the differential equations, but using neural networks. So the important part as far as the mathematician's role is concerned is to actually give us the basic fundamental differential equations which are actually governing that phenomena, so that we can actually you use that differential equations to generate our training and testing data set, and that can actually help us a lot for generating our this synthetic data which we can use for training our models. Are you getting my point? So without mathematicians, I think it's not feasible.
Yeah. Okay. Thank you. Is there any paid software we can buy? Like any? Is there any
Paid software for what?
for machine learning and all?
There is no need to pay anything. It's all freely available now. Even the education is also completely, free for machine learning, deep learning. So I don't suggest to buy any software for that. The only thing that you require is the graphical processing unit, GPU, that you have to buy, and that depends on your actually area. Like if you are working on very advanced architectures which require very high computation, then I would suggest you to buy a graphical processor unit. Otherwise, Google Colab is more than enough for your job.
Okay. So basically, if I have a differential equation in data, then we can then there is a role of collaboration with some experts of machine learning.
Yes, data will be generated from that equations itself. For example, see, I'm not an expert in plasma, but what we discussed was like he has some, FDTT solver, which he has done it for his own area. So what we were doing was we were generating some synthetic data using that FDTT solver, and using that solver, we generated the data and we were using it for our own, research. So the basic idea was to increase the computational and to decrease the computational time, which is done through conventional equations.
Okay, thanks. Thanks a lot. I'll get into more about you through mails.
Okay. Okay. Thanks. Thanks.